Today we're looking at inverse functions. So inverse functions in specialist mathematics is just finding the reverse of what we talk about functions. And in order to understand inverse functions itself, we're going to go through the four different properties of inverse functions, explaining how they come about and looking at why they're considered the inverse. So let's start off with the first one. The first and most common one when it comes to inverse functions is one-to-one. An inverse function must be one-to-one. Well, what does that mean for one-to-one? Well, it means that for every input, there's only one output. So one input will give one output. So that's what one-to-one is. It's going to make a lot more sense when we start looking at the graphical parts. So a linear equation is a one-to-one. We get one answer when we put one value in. So if we're looking at this here, let's have a look at a couple of examples. So let's look at x and x squared. So -2, -1, 0, 1 and 2. If I was looking at this here, I would get 4, 1, 0, 1 and 4. What's happening here is that I've got many to one. I've got many to one that's happening. So I've got multiple answers. I'm getting two answers of the same value from two different points. And we know that from functions, that really is something we've learnt from. When we look at one-to-one, for instance, if we look at x and apply this to x cubed using the same values, well, we get -8, we get -1, 0, 1 and 8. There is no repeating like you have over here. Everything here is 1-to-1. And that's the first real step when it comes to inverse functions. It must be 1-to-1. The second one comes about where we call it must pass. So it must pass the vertical line test, which we know is true when it comes to functions. So vertical line test, and it must end the horizontal line test. So that's the second property of an inverse function. So if we carry on with what we have just below these tables here, if we were going to sketch x squared and x cubed, so let's sketch those up here now. Okay. If we're going to sketch x squared just in its basic form, and then we'll call x cubed. Okay. I won't call that one. I'll do it the other way around, like it's not negative, still positive one. Okay. We can test the vertical and horizontal line test in this. So if we looked at the vertical line test, this here would pass that vertical line test because it doesn't cross any other value more than once. However, it does not pass that horizontal line test. And this here is the visual representation of what's happening up here. We've got more values for the same kind of data points. However, when we come to x cubed, we can see that this here passes the vertical line test, and then just as much as the vertical line test, it passes the horizontal line test. So for an inverse function to be considered inverse, one of those properties are, well, it's got to pass that vertical line test and it must pass that horizontal line test. When we start looking at this a little bit further, well, this here is the visual representation of what that one-to-one is. We can look at this a little bit further in terms of functions is the third one is all about the, well, what would I say here? The third rule one we can have here is that the function and its inverse are graphically reflections of itself. Reflections about the x equals y line. So that's our third rule. And we're going to look at this here right now. In order to be able to get that rule, we actually have to find the inverse function. And the steps that we take for finding the inverse function, which we'll look at right now, are as follows. So the first thing we do here is, our first step here is, we swap x and y in the equation. So we swap x and y in the equation. Our second step here is we then solve for y. Our third step and our last step here is we then replace y with the inverse notation part. So this here is the notation for inverse functions. So that's the notation, really important to remember. This here can be confused with something that looks like this. This here is not correct. So this does not equal the inverse in this type. So basically you need to remember that this notation here is the notation for the inverse of our function. So let's take an example. So we took an example here. Y is equal to 2x plus 3. So when y equals 2x plus 3, our first step here is let's swap the x and y around. So we'll have x is equal to 2y plus 3. We're now going to solve for y. So we get x minus 3 is equal to 2y. Divide both sides by 2. So I get 1/2 x minus 3 over 2 is equal to y. And then the last step here is we replace that y with the notation. Is equal to 1/2 x minus 3/2. And here is my inverse function of my original function up here. Really important that we do this correctly, so that way when we start graphing, this is what we're going to do right now, is that we get that reflection along the xy axis. So let's have a look at and graph this in this essence. So if we graph this correctly, and I'm going to do as best I can. Let's write these up here. So we're going to have y is equal to 2x plus 3, and we'll do in red. Let's do it in red. The inverse function is 1